Use logarithmic differentiation to find the derivative of y equals x plus 5 all over x times cosine of x. All right, now I do give you a hint here, right, or a method. I say use logarithmic differentiation. Can we use this, just use the normal way, right, the quotient rule in this case? And the answer is yes, right? The quotient rule is possible, but I mean, we got the product rule here, we got a trig function, which is fine, right? But let's take a look, right? Why would I suggest using logarithmic differentiation here? And well, actually, what is logarithmic differentiation? Okay, so the reason why we use logarithmic differentiation is it is just another method, okay, but it's easier to split this guy up. Let's see what I mean. Okay, so the first thing we do is we take the natural log of both sides. Okay, so the natural log of y, or the ln of y, equals the ln of this whole thing, right? X plus 5 all over x times cosine of x. And why do we do that? Right, the reason is, if you look at the right side, we can use the laws of logarithms to expand this, right? So we're gonna how can we rewrite this? It's going to be the ln of x plus 5 minus the ln of x minus the ln of cosine of x. Okay? So what we've done is we've used the laws of logarithms to expand this expression on the right side. Now we can take the derivative. And you notice, well, wait a minute. Yeah, taking the derivative of these log functions is a lot easier, right? Now, at this one, you got to be a little bit careful, right? Remember, what we're doing is we're taking the derivative with respect to x, right? This doesn't have an x in it, but we are assuming that y is a function in terms of x, okay? So whenever we take the derivative, in this case, right, we're going to use implicit differentiation, right? So what's going to happen here? The derivative of ln of y is 1 over y, but because we are taking the derivative of this term with a y in it, we need to multiply that by dy dx. That's by the chain rule, okay? Now what is the derivative of ln of x plus 5? Well, that's just 1 over x plus 5 times the derivative of x plus 5, which is 1. So we don't need to multiply by 1 here. The derivative of ln of x is just 1 over x times 1 again. Okay. Here, what is the derivative of ln of cosine of x? Well, it's 1 over cosine of x times, though, right, by the chain rule, the derivative of cosine of x, which is negative sine of x. Of course, we can simplify that, right? Sine over cosine is just tangent of x. Also, this is not the final answer, because we haven't solved for dy dx, right? In order to solve for dy dx, we need to multiply both sides by y, right? Because we don't want this, right, on the left side. So we're going to multiply both sides by y to cancel it out. On the left, it's going to pop over on the right side. What do we get? 1 over x plus 5 minus 1 over x. Once again, this becomes a plus, and sine over cosine is tangent plus tangent of x. And last thing we should do is we should replace the y, okay, with the original function here. Okay, so we get x plus 5 over x cosine of x times 1 over x plus 5 minus 1 over x plus tangent of x. Okay, now, it does look a little bit messy. I'm sure we can do, keep on going a little bit further and try to simplify this guy, right? But for all intents and purposes, we can leave this as the final answer. This is the derivative.